Welcome back, everyone. This is video 2.1, Hess's Law example problem number 1. So the question for this video is, what is the molar enthalpy of formation for the following reaction? So we're also given some other reactions here. So we want to find the molar enthalpy of formation for nitrogen dioxide gas. So we have some steps here to solving Hess's law problems. So we also saw this in the last video. Pause it here if you'd like to reread them. So let's check if adding up the two known reactions gives the target reaction. So our known reactions are right here, and we also know the enthalpies for those reactions. So let's add them together. And if we do that, we can see that the left sides are going to stay on the left side, and our three chemicals or compounds on our right side stay on the right side. So we have two N2O4 gases here. So that's our whole left side. And then the right side here is these other three constituents. And also recall that when we add two reactions, we need to add their enthalpies. So that's our delta H here. We can add them up as well. Okay, is this our target reaction? No. So we're going to have to do something else. We're going to have to manipulate the reactions that we are given. So let's manipulate these given reactions so that adding them will give the targeted reaction. So, and you can recall here our nitrogen dioxide target reaction here and our known reactions at the bottom. So let's see what we notice. We know on the left side of our equation, we want nitrogen gas and 2 moles of oxygen gas. Well, that's in equation 1. That's the right-hand side of equation 1. So if we want our target reaction, we're going to have to flip or reverse this reaction. So we think this is going to give us the answer. So we reverse this reaction. So basically our right-hand side becomes the left-hand side, and our right-hand side becomes the left-hand side. But we can't stop there. If we flip this or reverse this, we also need to change the sign on delta H. So we had negative 9.6 kilojoules. When we flip it here, it becomes 9.6 kilojoules. So our negative became a positive. So now that we have that, let's add the two reactions and see if the target is obtained. So notice here, this top equation is our newly manipulated equation. And we add them together. So the left-hand side of both is going to be the left-hand side of our result. And same with the left-hand or the right-hand side here, sorry. And now what do we notice? So we have a element on both sides. But other than that, it's starting to look like our target. if we have something on both sides of an equation, if we think mathematically, then they cancel out. And the same thing is going to happen here. So if we simplify this, we get our target reaction here. And just going back to this, we can cancel these because when this reaction happens, we have 1 mole of N2O4 gas before the reaction. After the reaction, we have 1 mole of N2O4 gas. So it was the same before and after, so it didn't change. So we can take that out and we're left with our target here. And remember that when we add these reactions, we need to add the delta H. So we have our 9.6 kilojoules and our 58.2 kilojoules. We add them together to get 67.8 kilojoules. Okay, now are we done? Matches our target. So we have a delta H. But recall what the question asked. So at the beginning of this video, we said we were going to find the molar enthalpy of formation. So the key word in here is molar. So that means we want the enthalpy of formation for 1 mole. And let's look at our equation here that we got. So what was formed here? The formation of nitrogen dioxide. And this 2 in front is our 2 moles of nitrogen dioxide. So that means we found the enthalpy of formation for 2 moles of nitrogen dioxide, but we need to find it for 1 mole. So we divide our delta H by 2. Because we have 2 moles, we want 1 mole, and then we are left with a delta H for nitrogen dioxide, nitrogen dioxide of 33.9 kilojoules per mole. It's important to remember that if you're asked to find the molar enthalpy of formation, that you should have units of kilojoules per mole. And was this reaction exothermic or endothermic? Pause it here and think about it. So remember from our last unit that if we have a delta H greater than 0, then we have an endothermic reaction. And that means heat goes into the system, so the surroundings get colder. So our answer for that is endothermic. This is an endothermic reaction. So there's a link in the description of this video that will take you to the Hess's Law worksheet. Please get that out. Try the first question on there. If you're feeling comfortable with these questions, then keep working and complete the worksheet. If not, then watch this next video.